Good morning, everyone. Welcome to our webinar on building a UK lithium valley. Just want to check, can you see the slides okay? So I assume that's okay. So yeah, let's make a start. So my name is David Stewart. I'm the Engineering Director for Research and Innovation at HSSMI, and I will be your host and the chairperson for the discussion during the session today. So today we are joined by 4 fantastic speakers this morning who represent some of the most exciting activities happening in the UK battery space at the moment. There's quite a lot to squeeze in over the next hour, and we'd very much appreciate your cooperation to help it run smoothly. This means please stay on mute for the duration of the session, except the speakers, of course, and provided that we've got time at the end of the session, we'll conclude with a panel discussion where you'll get the opportunity to ask some questions to the panel, but please do this through the chat function within Teams. So I just want to check, I think there's been a number of people have joined, so we've got a pretty full session. There's maybe going to be some more as we go. Just wanted to do a quick check-in there to make sure everything was okay. And yeah, I think we'll make a start. Still more people coming, but lots to get through. And I know that a lot of you are here to hear from the speakers. So let's get started. So firstly, for those of you who do not know who HSSMI are, we are a sustainable manufacturing innovation consultancy whose vision is to help companies to transform their manufacturing competitiveness to drive net zero. In essence, we do projects which help manufacturers grow, but not to the detriment of our environment. So naturally, the area of batteries is a very interesting topic for us from this perspective. It is absolutely critical as we are developing the UK supply chain, which we've called the Lithium Valley today, that we ensure it is economically, environmentally, and socially sustainable by design, all the way from raw material extraction and processing to cell manufacture, pack manufacture, to use, end of life, and then recovery. So to achieve this, this requires systemic thinking and collaboration, and that's why we've organized the session today to bring together the key stakeholders in the UK representing each of these areas to try and make this a reality. So after today ends, we do not want the conversation to stop. We are keen to organize more sessions like this, and we're excited to hopefully join up and collaborate with many of you moving forward. So onto the agenda. We will firstly hear from Robin Foster, who's the technical specialist in battery technologies at HSSMI, and he's going to be presenting some insights on what impacts Gigafactories are going to have on the wider UK battery ecosystem and stakeholders involved. We will then hear from Peter Rolton, who's chairman of Britishvolt, on the process they followed when selecting their manufacturing site. And there's a bit about Britishvolt and some of the activities that are happening at the moment there from Peter. We will then hear from Jacqui Murray, who's the Deputy Director of the Faraday Battery Challenge, and she will present her presentation on how the UK can prosper from the net zero transport transformation. And then the last speaker that we've got today is Sam Haig, who is Battery Recycling Business Manager at RS Bruce, and he will be presenting some insights on some of the key considerations for planning end-of-life recovery, as well as what RS Bruce are doing at the moment. And then we will conclude with our panel discussion where you can pose questions to the speakers in the chat box, and I will facilitate this discussion. Okay, so without further ado, I'm pleased to pass you over to Robin Foster, and he will present his slides. Robin.
Thanks, David. Yeah, so I guess what I'm hoping to do in this session is just highlight what gigafactories are and how relationships or lack thereof can impact the efficiency and competitiveness of our battery manufacturing ecosystem. So during this, I hope to introduce the topic and also tee up some points for the following presenters as well. So just going to the next slide. So this is a diagram that many of you may have already seen before, and I think Sam and Jacqui will touch on this a bit later. For those who don't know, this represents a circular model for battery production. So up in the top left, we've got our electrode material production feeding onto cell battery pack manufacture, and then onto the application for that battery. And then we've got the reverse supply chain. So ideally, opportunities for collection, remanufacturing those batteries back into their first application, repurposing them, so things like second life activities, and then ultimately where we want all of it to go is into a material recovery stage. So ideally recycling, where we can feed back into that initial step. So in 2017, when HSSMI, we started talking about this through a Faraday battery challenge project called Valuable. And at that stage, things were relatively disjointed, and there were sort of pockets of innovation happening, and especially in the reverse supply chain area, there wasn't really the material flow to support business. But I'm sort of delighted to say in 2021, there are stakeholders in all areas now within the UK. Already are in production. We're starting to see those volumes of materials moving through, and there's lots of sort of planned facilities going on as well. So this represents a rare opportunity where we're building an industry up from scratch, and giving us a chance to build an ecosystem strategically and not necessarily just organically as well. So this helps us support competitiveness against other countries that are also in a very similar position. So it's an opportunity that we really want to take advantage of. So if we just go on to the next slide. So one of the big parts of this is building a gigafactory. That's one of the remaining areas that we need to get this, as they say, sort of material flow and supporting the rest of the supply chain. So we touch on the numbers first. So what we've got here are some really good rules of thumb associated with gigafactories. There's a reasonable amount of variation in this, but this is pretty representative. So in terms of time to construct, we're looking at 3 to 5 years, 5 years especially when you're considering all the planning stages and the funding before it. So we're looking at like 2025, 2023 for the ones already in motion. Cost to construct around $100 million per gigawatt hour. Energy requirement, again, sort of 40 to 65 kilowatt hours of energy required per year to support 1 kilowatt hour of cells. So quite a lot of energy requirement there. And footprint, about 10 to 20,000 square meters per gigawatt hour. This is when we're looking at really, really big buildings, when we're looking at our current generation of 30 gigawatt hour facilities. For those that are going up and up towards the 90, 100, these are going to be some of the biggest buildings to ever have existed. So these are, they're big. They're not just big factories, but they're very, very big factories. And then the final point, which I feel is most important to touch on while we're going through this session, is the material cost. And that's something I think a lot of people are aware of. But again, just another rule of thumb there, for your annual electro material cost is around $50 million per gigawatt hour. So for a typical balanced gigafactory line, we're looking at around 4 gigawatt hours of production. So that equates to about $200 million per year per line. So they're big numbers. So what this leads on to is, if we just go on to the next slide. I don't know if it's tipped. There we go. Is that the sort of key themes of where, as a nation, the UK, we can try to be competitive as other countries that are going through a very similar position to us. So yeah, there's opportunities that we can definitely capitalize on. There's things that are common across everyone. So if we assume something like material costs are, if we're not focusing on changing them, they are likely to change, but this could be universal for all manufacturers. And similarly, processes, specifically for gigafactories, the processes are relatively well defined. There are obviously improvements coming through and sort of step changes there, but again, this might be something that a lot of people can access. So what this leaves us with, and what I'm focusing on today, is the gaps in between those. So we can identify those inefficiencies and hopefully capitalize on them. And this is where we feel we can be strategic and where collaboration and discussions are really important. So there's three main themes is where we've landed. So one is maximizing on high value materials, reduction of non-value add processes, and target support from industry, customers, and government. So this is making sure all those conversations are happening. So the first one, the maximizing high value materials, is really, really important. Any material that's lost within that process is potentially prices that's passed on to the consumer, potentially leading to non-competitive product pricing. So something like a 30 gigawatt hour facility, a typical one, will see around 15,000 tons of waste, of in-process waste generated. This is not something you want to see, but again, it's common globally, a typical yield. So it's something that we should capitalize on how we can recover any of that cost back and hopefully retain those materials within the UK. So we just go on to the next slide, David. So within those three themes, there's areas that we see fit into this, and I'm not going to go on to all of them within this session because we have a limited time frame. But I just want to highlight some key ones and just sort of stir up some conversation possibly in the discussion at the end. So something that we've seen is critical in other countries and will definitely be important for us is co-development and critical partnerships. So again, we're looking at gigafactories, big investment, which means we need support from the rest of the industry to make sure it's successful, to help de-risk that process. So if there is critical partnerships, one of the big ones is understanding what the factory needs to produce early on. There's a point where it starts to get difficult to design, as much as the processes are relatively well defined. There's a point where you need to start getting the tooling right and all of that sort of thing. So as I said, high cost material, if we're having to do late stage revalidation trials or retooling, that can, again, add to inefficiencies within that scale up process. Aiming for supply chain simplification, things like testing at both ends. If we're reducing distances, things like that, can we start to be more efficient with these processes? Data transfer, specifically in the reverse supply chain, this can enable things like higher quality recycle streams and also reducing the diagnostic processes as well. So the things we understand, but if we can start to tick off a lot of these processes, it can help move things forward. And one of the big ones is feedstock security. So not only does it build confidence and reduce, build confidence in the supply chain, it also can help to unlock investment if there's a sort of security of things going forward. So if we just go, maybe we'll do the next two slides, we'll bring everything up at once. And these are the sort of final areas that we see benefits in. So stakeholder location, co-location, I think Sam will touch on that a bit later, but also by shortening our transportation areas, we can start to enable things like reusable packaging and smart packaging where potentially monitoring and things like that can be used. Finally, we're getting on to government support. So ideally, there's things like capital funding to help accelerate processes. But other things that are really important, like infrastructure. So we're encouraging industry and consumer engagement, things like training that, things like the UK BIC have helped to support, not only in the workforce, but in people helping to build factories and the learning outcomes from that. And then finally, I think, again, Jacqui might touch on, which is like legislation standards. So being able to provide clarity simplifies the scale-up process, encouraging more people to come to us. It's not necessarily about reducing standards and making things easier. It's about doing the legwork now and reducing barriers and things that come I think I'm just about out of time, David, but that was a quick rattle through some of those areas.
No, that's great. Thank you very much for that, Robin. Of course, we don't have time for questions. If there is any questions, please put them in the chat box, and we will try and address them at the end. But what we'll do now is move on to our next speaker. So it gives me great pleasure to introduce to you Peter Rolton, Chairman of Britishvolt. He's going to present some of the work that Britishvolt have been doing, specifically around site selection. There is a video in this. We did a test before, it seemed to work okay. Should work okay. Hopefully technology doesn't let us down. And Peter, ready when you are to go ahead.
David, thank you, and good morning, everybody, and thank you for having me today. So next slide, please, David. Okay, this is me, Peter Rolton. So I'm a chartered engineer by profession. I actually have a company called the Rolton Group, which worked on the pre-site selection, which I'll talk a little bit about in a minute. So I'm a chartered energy engineer, chartered mechanical engineer, and a chartered building services engineer. So I came to this project very much through the engineering route. And as of January this year, I became a full-time employee at Britishvolt and left my other directors and shareholders to get on with running the Rolton Group. I was attracted to do this because it is the most fantastic project, and it's absolutely key to securing the automotive industry in the UK. Next slide, please. Okay, how did this come about? So UK government decided, I think partly on the back of Dr. Ralph Speth saying to Theresa May, basically batteries have to come to cars, or cars are going to go to batteries and leave the UK, that they better do something about it. And they set up a task force, and the Advanced Propulsion Centre, which is based out of but not part of Warwick University, was given the job of identifying shovel-ready sites in the UK for gigafactories that could be put in front of potential, gigafactory manufacturer developers. I was brought into that by virtue of work I'd done previously as a government advisor to help look at the sites that were being considered and to find the ones that were the most suitable. The way they went about this, because gigafactories do have a fairly specific set of requirements in terms of things like size, grid connection, other support infrastructure, was to go out to local enterprise partnerships with a questionnaire, quite an interesting questionnaire, grid connection and location nearest bus stop sat in the same place. Needless to say, what we got back was a fairly mixed bag of sites, some of which were completely unsuitable, but some of which were actually little gems that had been hiding away. We went through that exercise, identifying the best ones, and Camis up in Northumberland, which I'm going to show you in a minute, that was one of them, in my opinion, and stand out by far and away the best one. Next slide, please. So where are BV? Well, BV was only founded in December 2019, so not very long ago at all. In fact, it's a startup company. It's going through the gears at a phenomenal rate of knots. We are absolutely sprinting here to try and get a factory into production by Q4 2023. If you look at how long it has taken other people, you will see it's taken them many, many more years, but we are going extremely quickly. Part of that is because the UK government has created this ecosystem to support us. Obviously, you've got people like HSSMI, who we're working with closely, but you've got the APC and UK BIC, Warwick Manufacturing Centre. These organisations are vital to us because they enable us to take giant steps in our sort of process in terms of development of our product and to leapfrog large chunks of capital investment such that we can go straight from idea to effectively get a site and start building whilst in parallel doing the development and R&D work. So that's been a big factor in one of the reasons we come to the UK, and it's one of the reasons that we're able to move so quickly. We've actually selected the Camis site. We did look briefly at Wales. The Welsh site, unfortunately, had numerous infrastructure issues that meant it would not be able to come forward probably for about another 3 or 4 years to be suitable, whereas the Camis site was ready and available right here and right now. So we put a hand up for that in December. We've already appointed our tier 1 contractor. So again, we've got a contractor and a builder working with us to get ready to start construction before we've even bought the site. We then bought planning in 1st of March before we bought the site. We then actually did buy the site in April this year. We're expecting the planning decision in July. So that's, and anyone who's ever done any land purchasing or planning decisions will know those are very, very short timescales to get things of this scale done. We'll start construction this summer. We intend to build this factory in about 2.5 years and be in production by Q4 2023. Next slide, please. Okay, so what are we looking for in the site? Well, first and foremost, the most important thing you need in the Gigafactory site is the grid connection. It was mentioned earlier, the battery manufacturing process is hugely energy intensive. UK national grid is largely overloaded, has very little spare capacity, and a typical conversation with them around a grid connection for this, because the other thing is you don't actually want to go via the local network operator, because of the way the non-commodity charges work on the grid. There's big savings to be made if you get a direct national grid, non-DNO connection. And typically, if you ring up and you ask for one of 150 MVA, probably the phone goes quiet or some giggling at the other end, because it's such a massive, massive thing you're asking for. Once you actually get their attention, you're looking probably at 4 or 5 years, 50, 60 million pounds to get that grid upgrade done and in place. Now, no one has a business plan that says, we're going to build a factory, let's start by waiting 4 or 5 years. Okay, so from that point of view, finding a site with a good to go grid connection is the gold dust. It's the keys to the kingdom in terms of getting one of these factories up and done and running. We've been able to do that with the site I'm going to show you in a moment. Another thing about our site, it's big, it's flat, it's vacant. It's got fantastic connections to renewable energy. We've got the Norwegian North Sea link in the field next door with hydropower on it. We've got local wind farms we can put behind the meter. We've got a workforce in the area. We've got high unemployment, low skills. It's the perfect place to come, upskill, level up, train people, and to have a good, motivated, available workforce. So, we've been very much welcomed with open arms by the North East business community. And, we are absolutely nailed on intending to fulfill on those promises. ATF application, I think it's no secret that we've made a substantive application to the ATF, which we're waiting for determination. Then lastly, logistics. Our site's got fantastic logistics, which again, I'll show you in a moment. Next slide, please. Well, this is what the site used to look like. So this is in the 1960s, we think. You can see the 2 coal-fired power stations at the top, okay, from a different era of carbon intensity, I think it's safe to say. The site we've actually bought is the one where all the coal stocking is actually shown there at the moment. It looks very different now, as you're going to see in a minute. The 2 coal power stations were demolished in the year 2000, and the rest of it is all sat completely derelict, empty, adding no value, no jobs whatsoever to the local community. So this is very much a brownfield regeneration project. The good thing, of course, is that the power stations had to have a massive grid connection at 400,000 volts. That didn't get taken out, so that was still there. So that was the big driver to bring us to Camas. Next slide, please. Okay, so this is the video.
This site could be tailor-made for Britishvolt's battery gigaplant. Perfect transport links, including a deep water port, are just meters away. It's a coastal location with access to almost unlimited renewable energy from wind power and hydroelectricity from the unique North Sea link. We at Britishvolt are relishing the chance to regenerate the site itself, transforming a former power station coal yard into a facility producing world-class batteries that will be powering our electrified future. We will provide jobs to and secure a better future for thousands of local people. Working with the County Council and Advanced Northumberland, geotechnical experts are now taking soil and other samples, drilling down to different depths. We are deploying time, resource and considerable capital to ensure the site is ready for our needs. Samples are lab tested looking for environmental contamination and assessing the ground to help inform the structural design of our gigaplant. Results so far are extremely encouraging. We'll know for sure in a matter of days, but the future looks bright and we're keen to progress as quickly as possible.
Thank you. Next slide, please. So that video was shot at Christmas. That was us doing the ground investigation works before we bought the site to check for contamination. And despite you might look at that site there today and think, gosh, I bet that's a contamination nightmare. In fact, it isn't, not at all. It's just a bit dirty from all the coal dust that's been piled up on it. It is in fact not contaminated. We found one little bit of diesel spillage, That's the lot. Okay, so again, it's big, it's flat, it's empty, it's vacant. It was available. You can see the grid connection building, affectionately known locally as the cattle shed, top right. It's the only site in the UK that we found where you can actually simply buy your own transformers and switchgear, put a cable across the road, plug in, and get going. You can see the port at the top. We've got deep water port access, grid connection. We're putting the railway back in as well. And this site essentially has everything you need to get going as quickly as possible. Next slide, please. This picture here is just from a different angle. You can see the North Sea link in the top right there, which has been built since the earlier pictures were taken. That's the 1.4 going up to 2.6 gigawatts of hydroelectric power. Comes away from Norway on an AC/DC/AC link. That goes on to the cattle shed grid connection. It means that we can access very easily 100% renewable energy to power the factory and to make our battery that we're going to produce as lower carbon as possible. Next slide, please. The factory itself, they're big. Okay, as was mentioned earlier, ours is in the order of 2.7 million square feet or 3.4 million square feet with mezzanines internally. If you want to go out the front door at lunchtime and walk the perimeter of the factory for a bit of exercise, it's a 1.3 miles per lap. Okay, so that gives you perhaps a little bit of the idea of the scale of it. Down at the bottom there, number 7, you can see that's where we're putting our own private substation directly off the national grid. That's going to be at 225 MVA, 66,000 volt. We will use that not only to power our own factory, but also to do our own fully integrated vertical supplier park. Next slide, please. That's another image of it, again, just to give you a bit of scale. Those little wee sticky things at the bottom sticking out the back of the factory, they are a full-size articulated lorry. We will have 28 megawatts of solar just on the roof. Okay, it is a huge project by any stretch of the imagination. Next slide, please. And this is where we hope to get to eventually. We're currently assembling other parcels of land in association with the Local Authority Development Corporation of Advanced Northumberland. We're looking to build out, the various principal components of battery manufacture, bring our supply chain as close as possible, again, to reduce carbon footprint. Our ultimate aim, produce a battery from scratch in the UK with all the components without reference to other parts of the world, in particular without reference to China and Asia from a security of supply point of view. Okay, next slide. I think that's the last one. It was indeed. Okay, so thank you very much for your time today.
That's great. Thank you very much, Peter. Really interesting to see the work that's been going on. And I think some genuinely interesting insights to some of the people, some of the attendees on the call this morning who represent organizations who are trying to go through high growth and rapid upscaling as well. So thank you very much for that, Peter. Okay, so next up, we will hear from Jacqui Murray, who's Deputy Director of the Faraday Battery Challenge. Over to you, Jacqui.
I don't remember to turn the mic on, David, and the video on. Good morning, everyone. I thought I'd talk to you today following Peter's presentation, really around sort of all the measures that the UK are taking to not just transform, because I think in the public we always talk about what consumers are doing, but actually what we're doing to make sure the UK can prosper from the net zero transformation in transport, and we're all part of that journey. So I think seeing it from the oversight point of view might be useful. David, if you want to move it on. Okay, so look, on the 20th of April, Boris Johnson announced that this recommended carbon budget from CCC was actually going to be put into law alongside our net zero commitments. The bit that's interesting for me is the first major economy to legislate that pathway. That's a huge step change. You can see how it's come down since 1990, but actually a lot of that coming down has been done in different ways through the grid, through industrial. And actually for transport, we've stayed pretty stubbornly level. So it's a really interesting moment to see that set in law. And it's a big change. So whilst it's going to be a continued change for other sectors, For us, it's a bit more. David. Lovely. So what I wanted to do with you guys is split that up. So what does that net zero the politicians talk about actually really look like? And I know these slides are very small and busy, but I'm just going to get you the general principle. You can go and look on the CCC website, download the report. These are actually Bayes figures. And really what it shows you, the left-hand side, if you look at the bright orange, that's actually the amount of saving for CO2 or CO2 equivalents, I should say, from electrification. So we keep talking about electrification. You heard in Peter's presentation all around the solar and the grid connection and the renewables. So actually the transformation to electrification, not just for transport, for other sectors, is huge. The second graph is actually showing you a really nice Pareto and line graph of actually what that means. That purple line that comes down from about 120, if you can make it out, down to 0 is transport, surface transport. And that shows you in the bar graph that that's the biggest net change of all of those electrification sectors. And okay, so that's us and that's what we're doing. If you then look at the next one, when you break up surface transport, what's the biggest areas? And the pale green and the pale blue are passenger cars and vans. So again, you can start to see, well, this is why we're so interested in passenger cars in particular. When you then look at the last one, it's actually the transition predicted for people from to move into electric vehicles, the bright blue being full electric and the pale blue being hybrid. The graph on the right just shows you about charging. So David, if you move on, what I wanted to also show to those listening in was very much how this was around a moment in 2016 where the car industry realized if you did your climate change calculations, you could extrapolate to 2030 what your average fleet CO2 was going to need to be as part of that pathway across Europe. And what they realized was actually that in 2016 that there was a step change needed that was much faster than transitioning through hybrid to full electric. That actually by 2020, 2021, by today, they really needed to be putting full electric onto the market in great numbers. And what you've seen, I think, is a reaction to that. If you look around you and if you look at people's perception of what they're going to be driving as the next vehicle, actually that's it. But through all of this, it's really important that as we see those pathways come, that we can make sure our manufacturing industries can prosper. So if we do take passenger cars for a moment, the reason that was such a immense realization was because in passenger cars, there's about a 10-year lifespan on manufacturing a platform and architecture. So if you're in a Fiesta and all its derivatives, actually the same architecture is going to be manufactured by the company for 10 years. It's why you get facelifts and you get tweaks to the engine computers in terms of giving you a few extra horsepower so that consumers feel that they're in a newer car, but actually it's the same car, it's the same big £1 billion investment, and the design and development has been done for the full 10-year production. So I'm sat there in 2016 and I need to hit a 67 grams target by 2030. You can see how by 2020 I needed to have made a significant shift in what we're doing in terms of manufacturing. And if you look at automotive in the UK, we're actually a big automotive manufacturer. It's been hit over the last few years, but in 2016 we were making about 1.7 million cars. What's interesting is the reason we make so many cars is because we make 2.5 million engines. We're very good at integrating propulsion systems, and I know Peter works alongside people like Isabel Sheldon, who has sort of designed and engineered quite a few of those vehicles over time, and actually making cars things we want to drive, efficient and also fast. You look at our motorsport industry, actually that's what the UK's USP is. So we really needed to make a move. So David, if you flip on a slide, and as engineers, basically what we did was we decided that the Faraday battery challenge that was going to come forward was going to need to be really focused around the 8 key challenges. And the numbers in these boxes change depending on your duty cycle, on your application. But we know that cost of batteries and cost of battery manufacturing, I'm sure that's on number one on Britishvolt's list of attributes for their batteries, is being able to compete on cost, bringing down that price of electric vehicles in particular. The energy density, the range, the power density, which relates to both the acceleration of vehicles, but also the charge speed. So it's how quickly you can discharge a battery, how quickly you can charge it back up again. Safety being an issue. I know there's people on here looking at safe packaging, for example. So actually how we can keep the entire system safe is the challenge that we're working on and bringing together people. First life is a massive importance, and we look at things like 8-year warranties on electric vehicles. So you can see how being able to operate vehicles at different temperature ranges, being able to predict how they behave over the first life is incredibly useful. And then when it comes to sustainability, it's the intensity of all that, but also the ability to take those batteries and reuse or repurpose or remanufacture and actually finally recycle them. And the opportunity in the UK relates when you sit down with the car companies and you ask their procurement departments how many batteries they're going to need by 2035, they can very clearly tell you that it's around 8 billion in the UK. And so what you've got there is an opportunity, a market gap, and that's just for the cell manufacturing. So you can see that there's a supply chain element to that as well that really comes to the fore. We're talking to chemical companies, we're talking to materials companies, we're talking to component manufacturers, and we work with the Advanced Propulsion Centre to do that. So if you flip on one, I'll explain a little bit about the Faraday Battery Challenge itself. So this came out as a concept in 2016 and was launched in 2017. Initially, it was $250 million. It's gone up since then, I'm glad to say, and it's over 100 million into the Faraday Institution. And the Faraday Institution is, it's over 450 researchers, 10 major multi-institutional, multidisciplinary research that's very much bringing science and applying it to the engineering problems that we have out there. So if you haven't seen these before, I really recommend you look at them. If you were expecting me to say 9 projects, there's a new one on battery safety that's very close to my heart, really digging into the science behind electric vehicle batteries and what happens if they do get thermal runaway events, how you can manage it, how you can get better at it, but also very clearly what the hazard is. We have over 90 million going into collaborative R&D, and that's another hundreds of people you can look up and have a look at that. And then I know Peter and the team are very, very used to the Battery Industrialization Centre. I'm delighted to be going there next Monday for the first time, thanks to COVID. But that's where you can actually prototype and take your R&D away from the university bench, away from your companies as prototypes, and then start to run it at full manufacturing speed. That's the first of its kind in Europe. It's an incredibly important linchpin, and I know Britishvolt are pleased to have that facility within the UK, and it's open access for those across all of the UK. David, I think I'm running out of time, so if you want to flip over, what I would just make a pitch for is to become part of the innovation ecosystem if you're not already. Log on and search for the Innovation Network, the Battery Innovation Network that is hosted by the Knowledge Transfer Network. Register on there, join the landscape of companies. We're looking at collaboration. It's so important to that leap forward. Peter was sort of talking about, leaping forward, running at such pace. Actually, the only way you can do that is to make sure you've got access to all those government departments, all those researchers, all those engineers working in this space to really take some risks that are going to really pay off for the UK. And what we also look to do is talk to investors. So we've just run our first investor program. We've got great interest from green investors, private investors into this space. I'm sure Britishvolt as well can reflect on that. And we also want to talk to you about codifying your knowledge. So if you haven't seen the British Standards Institute, if you Google British Standards Institute and Faraday, up will pop the access to the suite of 3 standards they're standards written by 100+ organisations in the UK, just codifying what are the best health and safety and environmental procedures are. So David, I don't want to take up too much time, so I think you might have to flip through my last slides, which were just to explain a little bit about sustainability in batteries and funding landscape, but I'm sure we're going to share the slides afterwards, so let's find
Yes, thank you very much, Jacqui. And I think we'll hear from Sam next, a bit more on the sustainability side of things. Just want to say thank you very much for that, Jacqui. As always, very interesting to see what's going on at a strategic governmental level. And I know that there's a number of organisations on the webinar today who have indeed accessed some of the support from you guys and from the Faraday Institute and the Battery Challenge, and it's very much appreciated. So yeah, certainly endorse you guys to continue what you're doing.
Thank you.
Okay. So next up, we will hear from Sam Haig from RS Bruce. Take it away, Sam.
Thanks very much, David, and thanks everyone for your time to come and have a listen to me and the other speakers today. So yes, we've heard a bit about battery manufacturing, and Jacqui's given us a good rundown of all the kind of interesting research and investment that's going on. So I want to talk a little bit about what's happening at the end of the supply chain and how we can connect it all together. So if you just move on, David, thanks very much. So what we've got here is a very basic, simple supply chain, going from sort of the raw materials right to the end, the cell recyclers, and what is one of the big problems in my mind that you often find is, if you move on, David, that there's often this communications gap, which is all along the supply chain. People talk to the people just next to them, or perhaps a couple of steps down the chain. But then when it gets to the customers, there's this gap or chasm of communication, because often when batteries or items, and this isn't unique to the battery sector, it's in lots of other sectors as well, when items go to the customers, they sort of disappear as far as the manufacturers are concerned, because it's often quite difficult to keep traceability of them, and then they end up in the recycling supply chain, and it's very difficult to communicate back to the original manufacturers. So really, in my mind, what needs to be done is additional communication, and again, if you move on, David, you can see lots of additional links that need to be built either side of that gap to try and break it down. So I'm hoping that this talk is one of those additional links that can be helped to start this communication. Okay, if you move on a bit. One of the other difficult things that I've noticed quite a lot when having these conversations is how many different languages there are when it comes to batteries, specifically in terms of how you measure batteries, whether that be amp hours or watt hours, or cells or items, or weight of cells. You know, weight of a battery and weight of a cell is a different measure. So there's really a question to be posed there of how do we communicate that better, because a gigawatt hour for one cell might be a completely different weight of cells to gigawatt hour of another type of cells. And when I'm looking at how I'm going to make my supply chain or make my recycling facility sufficiently sized for the challenge of what's going to be coming down the track in 10 years, I need to know not so much how many gigawatt hours there are, but how many tons are going to be turning up in my gate. So it's understanding these different languages and trying to get them all to communicate with each other. Okay, thank you. And again, just as a bit of understanding, it's interesting to look at where all these different end-of-life batteries are coming from. So you have, for example, the traditional, or what you might think of the traditional supply chain of vehicle recyclers producing materials for recycling, and that's going to change in the near future to include batteries. Batteries are going to be coming out of that and going for recycling. But it's not just vehicle batteries, even though that is the big dominant technology. You've got electronics as well, and that's quite a incumbent supply chain already. You've got consumer recycling, And then you've got other aspects as well. You've got, for example, the service centres, the equipment manufacturers, OEMs, so manufacturing scrap and all that kind of stuff as well. And yes, as I say, manufacturing waste as well, which is a slightly different challenge to lithium-ion batteries themselves. And that presents lots of different decisions and challenges at end of life. I think it's been touched upon a little bit about whether centralised or hub and spoke is better, whether you want to have one big facility that sucks in lots from lots of different areas around it, or whether you have small pre-treatment facilities in local areas that then send material to a centralised processing facility, or whether even something like co-location is an opportunity as well with manufacturing. Also, there's that brings in the idea of consistency versus volume. Do you want to tie your colours to one specific supplier, knowing that I'm always going to get the same type of batteries every time, and therefore I can make sure that my facility is tuned perfectly to that? Or do I want to try and get a larger pool of batteries that isn't necessarily as consistent, but gives me a larger volume to go at? And then if you start doing that, you start looking at batching materials through, so you can be efficient and so on and so forth. And also, as I touched upon in the previous slide, you need to look at whether you're dealing with end-of-life cells or production waste, because production waste, as I say, is a different challenge. If you're looking at coated cathodes and anodes or other materials, then that is a different recycling challenge to fully manufactured cells. And the final point that I just want to make is there are lots of challenges that face the eco battery recycling supply chain. Training is one really big thing. There is quite a bit of training for sort of the manufacturing side, but then when it comes to dealing with end-of-life batteries, specifically around things like high voltage and so on, it's something that needs to be thought about, and provision for that is necessary. Things like pack design. I mean, design for recycling is a whole topic I could speak on for another 10 minutes, but I'm not going to. But just things like that, like understanding where's the right place to put glue, and my answer is the right place is nowhere, and other things like that. Things like standardization as well. So, for example, when it comes to communication with the batteries, if there's a standard set of communication protocols that could be used to determine whether a battery is suitable for second life or not. All these kinds of things are really important, and as I mentioned at the start of the talk, that all comes down to communication. So communication all the way along the supply chain, understanding from the manufacturers to the end-of-life recyclers. That's something that's really important. Okay, yes. So just to round off, just a couple of slides about what RS Bruce is doing in this sector, just to finish off. So by trade, we're a precious metal recovery business. We've been going for nearly 50 years now, and we're based in Sheffield, and yes, as I say, our core business is in precious metal, but we are establishing a lithium-ion battery recycling facility, which would be the first one in the UK. That would be operating on any kind of lithium-ion battery cell. You can move on now, David. To produce things like the metals and the plastics and the black mass as well, which can go on for further treatment through hydrometallurgical processes or so on. You can move on to the final slide now, David. So yes, that's something that we are establishing now, and we are processing batteries as we speak, just in small quantities, but over the next few months we're going to be growing that volume to up to our facility, our size of around about 1,000 tonnes a year, which is not enormous volumes, I'll admit, but is kind of the first stake in the ground before we move on to the the next phase. So I think that's all I've got. So thank you very much for your time.
That's great. Thank you very much, Sam, for that. And yeah, again, very, very insightful. And of course, you know, I guess we won't hit really high volumes of end of life batteries for a while, but it's really important that we do all this now to allow for, you know, supply chains to mature, practices to mature, standards, as you said, and to build into the design of cells and packs the ability to better recover at end of life. So really, really important work just now. Okay, so with that, what I'd like to do is we've got about 10 minutes left for our panel discussion. So what I will do is I'll stop sharing my screen. And if I can ask that all attendees, apart from the panelists, if you can remain on mute, that would be greatly appreciated. I'm going to have a look at the chat box to see what questions that we've got here. And as I do that, what I'm going to do is I'll kick off with the first question. So and really it's open to everyone to respond to. But where do you guys see the UK battery industry being in 2030? What will it look like? I don't know, maybe I'm going to pick on Jacqui first, you know, from that sort of strategic governmental view, if you've got an idea.
So although my presentation focused on passenger vehicles in the UK, I do think you're going to see factories in the UK by 2030 manufacturing for those supply chains. One of the things I think you'll notice in the UK by 2030 is the cross-sector applications of batteries. So somebody asked me about aerospace, for example, and we are closely linked into companies like Electrified, who are working with Rolls-Royce on a light aircraft that's going up in the next few weeks to try and break the airspeed record. I think you'll see people like JCB, others really bringing forward and manufacturing in the UK electrified vehicles. The other bit, and I think Sam will probably agree with me, is 4 years ago, talking about recycling of lithium-ion propulsion batteries was definitely felt like you were talking into a void. I remember meeting Sam, I think it was even in Germany, and people like Alan Coleridge at very specialised battery conferences. Whereas now I seem to have a weekly, if not daily, conversation about recycling. So there's these shifts that are coming. And I guess the timing for that makes sense, right? It's only when you have gigafactories with the scrap that comes off those, really active and actively looking like Britishvolt and others, and across Europe, where you start to really build that momentum, and then you're starting to see end of life leaf coming off. So for me, it's going to be a wider conversation about batteries by that point.
Thanks, Jacqui. Maybe Peter, what do you think it looks like from your perspective, and where do you think Britishvolt will be in 2030?
We obviously have the first factory fully up and running by then at all three phases. I'd expect us to be well into the weeds of probably the second and potentially even the third factory by then. Interesting to hear what Jacqui says. I mean, our own sort of experiences bears out what she says. We're getting inquiries coming now to us from multiple sectors, particularly a lot of interest around sort of light commercial van. The world is drowning in white van man at the moment, delivering Amazon parcels. They're all going to need to go electric, but also, you know, heavier, more industrialized things like buses and, as Jacqui said, JCBs. All those sort of companies are starting to make inquiries now about what they're going to need. So it's cars is the focus at the moment. Cars will not only be the only focus going forward. And I think the interesting thing there, of course, is that there is a lot of different requirements technically. The battery you need for a car is very different to the battery you need for a bus or the battery you need for a JCB in terms of its technical performance, its life cycles, its recharge performance. So an interesting sector ahead. I mean, we will need to find further suitable sites, and the challenge is going to be bringing those forward given the significant infrastructure upgrades around the UK to get stuff ready.
Yeah. Okay. Thanks, Peter. And there's a question I was just scrolling through. It's maybe relevant to this, and it's from Ed Cox. And the question is there an intention to apply circular principles to the whole life of the Gigafactory from design, build, and day-to-day operation?
Absolutely. I mean, the supplier parks that I put up at the end, we absolutely intend to have a recycling facility in there as well. And for the batteries to go out the door and to one day eventually come back to us after potentially have had a second life, perhaps starting in static storage somewhere. But I think we do need to recognise it needs to be a fully circular economy. We also are targeting producing a zero carbon battery with all green electrons on the electricity. The electricity price in the UK means we'll probably have to use some natural gas, at least initially, although we'll offset that with biogas credits to start with. Ultimately, we'd want to get rid of natural gas and switch to hydrogen as an alternative in due course when that becomes, a commercial alternative.
Great. Okay. Thank you. And a question for Robin from David Threlfall. So driving smart factory technology wasn't mentioned as an opportunity in your presentation to improve efficiency. What were your thoughts on this?
So, I mean, it was excluded because I was primarily trying to focus on, if material costs stay the same, if process stay the same, what can we do outside of that as an ecosystem? But in terms of smart factories, it's 100% needs to be involved. This sort of next generation of gigafactories are benefiting from that. There's, especially around the sort of electrode manufacture section, the first third, it's coming out of what was historically sort of disjointed process, where there are sort of independent stages, and now there's that level towards automation, which requires a higher level of the smart technology, but also in helping to improve the testing processes. So if we can start to identify or at least log what's happening in those processes early on, the final third of production is your formation, aging, and testing, and that is a big pain for everyone. It's a huge part of the factory. It takes a long time. You're talking weeks, and it's effectively a big storage facility and big energy costs. So there's certainly benefits of the smart factory element in sort of utilizing that to try and make these processes more efficient as well. I don't know if Peter has anything to add on to that. I'm sure it's something you're considering.
Yeah, well, we're absolutely going down the route of having a smart factory. We're doing digital. We're going to do digital twin, look at a lot of automation and things. That's de rigueur now in terms of what we need to do in terms of full system simulation. Also tying our digital twin model into our Revit model for the build as well.
Yeah. Great.
And I would add that those things are really important from a life cycle analysis point of view. We talk about sustainable batteries, being able to show the relative advantages of different technologies and supply chains is going to become really critical. Not just from a tree hugging point of view, but a regulatory perspective and exporting.
I think as well. Just on that, it touches on, I think, one of the questions that I've seen on the chat about the Global Battery Alliance and their battery passport, and I think that all ties in as well, which I think is something that's really important, and having that traceability all the way through the supply chain. Which would really help, for things like second life, and also understanding the most efficient ways of dealing with them when they finally come to their end of life.
There's some interesting thoughts as well, isn't there, about whether you sell the battery or only ever lease it? Do you ever actually, if you're a manufacturer, do you sell the battery to the OEM, or you just lease it and it's always yours, and therefore it always comes back at some stage at a later date?
Yeah. I think one of the things that needs to be thought about is the value of that battery, and if there's a value of the battery at end of first life, then it's going to be really difficult to get it back, because if there is a value to you, then there's going to be a value to someone else, and they're going to try and hijack that value. So you need to be you just need to think about the best way of controlling that supply chain. I think of an analog in the catalytic converter market, where there's no control of that supply chain because there's so much value. So that's something that really needs to be thought about quite carefully.
Good. I'm going to squeeze in one last question. It's from Alistair Hales, and it's on skills. So what skill set or capability does the private sector lack most at the moment to match the demand for lithium-ion batteries? And how can academia support the industry to overcome this?
Cell designers.
Designers.
Cell designers.
Cell designers. Yeah. Okay.
Yeah. We're basically wandering the globe, hijacking them off the streets at the moment. So, okay. It's a bit not quite the old-fashioned press gan, but it's a more sort of polite version of it.
I think
Cell designers.
I think from our point of view, it's as I touched upon, skills with high voltage systems, which I think is something that's in demand for lots of people, not just for us, and that's why it makes it so difficult. And having the training that is suitable for high voltage operators at end of life, not just for building them.
I think it's all skills. I mean, I'd argue when you look through the battery chain, every company we speak to that's growing has to go through some sort of activity to train up people that they're taking on. It's a lot of it is retraining and upskilling. So I'm sure, Peter, there's people out there that can be cell designers in the UK, but there's a gap between going from where they are to where they need to be, and your pace is so fast in Britishvolt. So I'm really keen that we continue the conversation and that high voltage live, Sam. My God, we even on a steelworks, which is my background, we used to have to get in the consultants from ABB and Siemens and people like that, because whilst we had a lot of high voltage engineers, you know, the live element of an electric vehicle battery brings in a whole new level of should we say exciting? So yeah, but I think at all levels, right? One of the aspects that I also see is, you know, all that maintenance out on the road. How are garages? How's my garage gonna maintain those vehicles? What the impacts are going to be? So from a government point of view, we also need to think about, you know, impacts on some of the businesses that are out there at the moment. And a lot of what we do is talking to companies that are very, very, very automotive internal combustion engine focused on where they can go and how they can get there. So by all means, keep the conversation going.
Perfect. No, that's
David, just one thing. I've seen a lot of very interesting questions popping up in the chat, and obviously we're out of time. Would it be possible for you to put the people asking them in touch with us all, so we can perhaps loop round with them afterwards?
Yes, indeed. Yeah. I think we can do that most certainly, and I think if it's okay with the speakers, and we'll just double check things. But if you're okay, we'll do that and share the slides, of course, with everyone today. But that's we must come to a close. We're over time. I think clearly we could discuss this topic for a very long time. Lots of questions still coming in, I think to Jacqui's point that she just said there, keen to continue the conversation as are we on this. I think what we will do is we'll come back to all of the attendees with some questions and to get some feedback on how you would best like to see this continued. We're very much committed to doing that. And I just want to thank all of the speakers this morning for sharing their insights and being so open and for answering the questions. And thank you very much for all the delegates for attending as well.
Right. Cheers, dear.
Thanks, everyone.
Great. Okay, thanks. Well, we'll be in touch over email with those next steps. And hope everyone has a great day.
Fantastic. Thank you.
Thanks a lot.
Thanks, everyone.
Bye.
Bye-bye.